The sky over occupied Europe in 1942 was a battlefield unlike any the world had ever seen. At altitudes where the air grew thin and the cold could freeze a man's breath in seconds, American bombers carved contrails through hostile skies. Among these aircraft, one machine stood apart from all others, the Boeing B-17 Flying Fortress, a name that struck both awe and terror into the hearts of those who encountered it. For the German engineers and Luftwaffe pilots who faced these machines in combat, the B-17 represented something they had never quite seen before. It wasn't the biggest bomber, it wasn't the fastest, but there was something about this American giant that defied logic, that challenged everything the Germans thought they knew about aircraft design and durability, and they were desperate to understand it. The story of how German engineers came to possess an intact B-17 and what they discovered when they tore it apart piece by piece reveals one of the most fascinating technical intelligence operations of the Second World War. It's a story of engineering brilliance, of desperate aerial combat, and of grudging respect between enemies. But more than anything, it's the story of a machine that simply refused to die. To understand what the Germans discovered, we must first understand what made the B-17 so special in the eyes of those who flew it. The Flying Fortress wasn't born from a single moment of inspiration. It emerged from a uniquely American approach to warfare, one that believed in precision, in overwhelming firepower, and in the ability of well-trained crews to fight their way to a target and back again. The year was 1935 when Boeing first rolled out what would become the B-17. The United States Army Air Corps had issued a specification for a multi-engine bomber, and Boeing's engineers had responded with something audacious. While other manufacturers offered twin-engine designs, Boeing proposed 4 engines. While others focused on speed or payload, Boeing's team emphasized something different: survivability. The prototype, designated Model 299, featured something unprecedented for its time: 13 defensive machine gun positions. The test pilot who first saw it supposedly remarked that it looked like a flying fortress. The name stuck. But the name alone didn't capture what Boeing had really created. They had designed an aircraft built around a simple but revolutionary philosophy. This bomber would be able to defend itself, absorb tremendous damage, and still bring its crew home. By the time America entered the war in December 1941, the B-17 had evolved through several variants. The B-17E model introduced the tail gun position that would become iconic, completing the sphere of defensive fire that made the Fortress so formidable. But it was the B-17F and later the B-17G that would truly prove the aircraft's worth in the skies over Europe. The 8th Air Force began arriving in England in the summer of 1942. Their mission was ambitious to the point of seeming impossible. They would conduct daylight precision bombing raids deep into Nazi-occupied territory and into Germany itself. The British had already tried daylight bombing and had paid a terrible price. They had switched to night operations, but the Americans insisted their approach would work. The B-17 was central to this strategy. Flying in massive formations, sometimes hundreds of aircraft strong, these bombers would present such concentrated defensive firepower that German fighters would be unable to stop them, or so the theory went. Reality proved far more brutal. The Luftwaffe had been the most experienced air force in the world when the war began. Their pilots had fought in Spain, in Poland, in France, over Britain, and on the Eastern Front. They had developed tactics for destroying bombers. They had cannons that could tear through aircraft structures, and when the Americans arrived with their flying fortresses, the Germans were confident they could handle this new threat. That confidence lasted approximately as long as the first major engagements. The German fighter pilots quickly realized they were dealing with something extraordinary. The B-17 formations flew tight. their overlapping fields of fire creating zones of death for any fighter that approached carelessly. The defensive armament consisted of 50 caliber Browning machine guns, weapons that hit hard at ranges the Germans weren't used to encountering from bombers. But what really shocked the Luftwaffe pilots was what happened when they did manage to score hits. Aircraft that should have fallen from the sky, that by all rights should have disintegrated under the punishment of 20mm cannon fire, somehow kept flying. B-17s would return to base in England with damage that seemed incompatible with controlled flight. Engines shot out, wings holed by dozens of cannon strikes, tail sections hanging by cables, and yet they flew. The German High Command wanted answers. How was this possible? What engineering secrets had the Americans employed? The Luftwaffe needed to understand this adversary if they were going to defeat it, and to understand it, they needed to get their hands on one. Not wreckage scattered across a field, not a bomber that had been torn apart in a crash. They needed an intact B-17, or as close to intact as possible. The opportunity came from several sources. Sometimes B-17s, badly damaged and unable to make it back to England, would attempt emergency landings on the European continent. Some crews, lost in bad weather or disoriented by combat damage, would land at airfields they thought were friendly, only to find Wehrmacht soldiers surrounding them. And occasionally, a B-17 would be forced down by fighters but survive the landing relatively intact. One of the most significant captures occurred in December 1942. A B-17F from the 303rd Bomb Group, aircraft number 4230051, crash-landed in the Netherlands after taking heavy damage during a raid. The crew was captured, but the aircraft, though damaged, was remarkably complete. The Germans couldn't believe their luck. The bomber was carefully transported to the Luftwaffe testing facility at Rechlin, north of Berlin. This was the primary evaluation center for captured Allied aircraft. Here, German engineers and test pilots would put enemy planes through exhaustive testing, looking for weaknesses, studying strengths, and trying to understand the design philosophy behind them. The team assigned to evaluate the B-17 included some of Germany's finest aeronautical engineers. Many had worked on the development of Germany's own bomber fleet. They approached the American aircraft with a mixture of professional curiosity and, it must be said, a certain arrogance. After all, German engineering was considered the finest in the world. What could these Americans possibly teach them? That arrogance began to crack the moment they started their detailed examination. The first thing that struck the German engineers was the sheer mass of the aircraft. The B-17F had a maximum takeoff weight of over 65,000 pounds. For comparison, the Heinkel He, A111, Germany's primary medium bomber at the start of the war, weighed less than half that when fully loaded. The B-17 was simply operating on a different scale. But weight alone didn't explain the bomber's legendary toughness. The Germans began with the airframe structure, and here they encountered their first surprise. American aircraft construction differed fundamentally from German practice. The B-17's fuselage used a semi-monocoque design with heavy longitudinal stringers and formers, but what really caught the engineers' attention was the skin. German bombers typically used relatively thin aluminum alloy skin, relying on the internal structure for strength. The B-17 skin was substantially thicker, but more importantly, it was installed differently. The Americans used a technique called flush riveting on critical areas, where the rivets were countersunk into the skin, creating a smooth surface. This reduced drag, but it also created a stronger bond between skin and structure. The engineers documented everything meticulously. They measured skin thickness at hundreds of points. They studied the alloy composition. They examined the riveting patterns. And they began to understand that the B-17's durability wasn't the result of one clever trick. It was the product of thousands of small decisions, each one adding a tiny increment of strength. the wing structure provided another revelation. The B-17's wing was thick by European standards, using a high-lift airfoil that sacrificed some speed for load-carrying ability and stability. But the internal structure was a masterpiece of engineering compromise. The main spar, running the length of the wing, was massive. The Germans had seen nothing like it on an aircraft of this type. What impressed them even more was how the wing was attached to the fuselage. The Germans used various mounting systems for wings, but the B-17's approach was different. The center section of the wing ran through the fuselage, creating an integrated structure. This meant that flight loads were distributed across a much larger area. It also meant that the wing could sustain severe damage to the outer sections without catastrophic failure. Test pilots at Rechlin flew the captured B-17, and their reports added another dimension to the engineers' understanding. The aircraft handled differently from any German bomber. It was stable, almost to the point of being ponderous. The controls were heavy, requiring significant physical effort. This was no fighter, no nimble machine for acrobatics. This was a truck, designed to carry a heavy load through terrible weather and enemy fire, and to do so reliably. But that stability meant something crucial in combat. Even when damaged, even when engines were shot out or control surfaces were holed, the B-17 wanted to keep flying straight and level. German bombers, more sensitive and responsive, could become uncontrollable with similar damage. The Americans had prioritized stability over maneuverability, and in the context of strategic bombing, that was exactly the right choice. The engines fascinated the German engineers perhaps more than any other system. The B-17F was powered by 4 Wright R-1820 Cyclone radial engines, each producing 1,200 horsepower. These were air-cooled radials, a design that German engineers had largely moved away from for large aircraft, preferring liquid-cooled inline engines. The Germans had good reasons for favoring inline engines. They offered lower drag due to their streamlined profile. They could be better armored. And German manufacturers like Daimler-Benz had developed excellent designs. But the American radials offered something else, incredible ruggedness. When the Rechlin engineers tore down one of the Cyclone engines, they found a power plant designed with massive tolerances and redundant systems. The engine could continue running with several cylinders completely shot out. It could lose oil pressure and still function long enough to get the bomber home. The air cooling system meant there was no vulnerable radiator to be holed by fragments. In combat conditions, these engines simply refused to quit. One German engineer later wrote in a report that the Americans had designed their engines as if they expected them to be shot. Every system had backups. Every critical component was overbuilt. The Germans had optimized for performance and efficiency. The Americans had optimized for survival. In the brutal reality of aerial combat, survival trumped efficiency every time. The defensive armament presented another study in philosophy. The B-17F mounted 13 50 caliber machine guns in various positions. These weren't light defensive weapons. The 50 caliber Browning was a heavy machine gun, one that German fighters had learned to respect. The Americans had essentially ringed their bomber with what were, by European standards, heavy weapons. But it wasn't just the guns themselves that impressed the German engineers. It was how they were integrated into the aircraft. Each gun position had ammunition storage designed to prevent jams, even during violent maneuvering. The turrets, especially the ball turret beneath the fuselage and the top turret, were marvels of mechanical engineering. They could track targets smoothly and accurately, even while the bomber was taking evasive action. The Germans had their own power turrets, but American turrets incorporated features they hadn't considered. The computing gun sights on later B-17 models could calculate lead automatically, helping even relatively inexperienced gunners hit fast-moving targets. The Americans had democratized aerial gunnery. making their crews more effective through superior equipment. Perhaps most impressive to the German engineers was the degree of crew protection. The B-17 incorporated armor plating in critical areas, protecting the pilots, the bombardier, and the waist gunners. But beyond the armor, the aircraft featured fire suppression systems, protected fuel tanks, and redundant control systems. The Germans realized that Boeing had designed this bomber with the assumption that it would be damaged in combat. The question wasn't if, but how much damage it could sustain and still complete its mission. The fuel system demonstrated this philosophy perfectly. The B-17's fuel tanks were equipped with a self-sealing system. When punctured, the rubber layers within the tank would swell on contact with fuel, plugging the hole. The Germans had similar technology, but the American implementation was more robust. Multiple layers, better materials, more effective sealing. A B-17 could take hits in its fuel tanks and lose relatively little fuel before the self-sealing did its job. As the months went by and the Germans accumulated more captured B-17s, they began to see patterns in the damage these aircraft could sustain. One bomber returned to England with over 300 holes in it. Another landed safely with 2 engines completely shot out. There were reports of B-17s colliding in midair, shearing off significant portions of their wings, yet still making it home. The German engineers compiled all of this data, and a picture emerged. The Americans hadn't built the most technologically advanced bomber. They hadn't built the fastest or the most efficient. They had built the toughest. Every single design decision, from the thickness of the skin to the redundancy of the controls to the power of the defensive armament, had been made with one goal: get the crew home alive. This realization forced the Germans to confront an uncomfortable truth. Their own bomber designs, optimized for different priorities, were proving inadequate for the kind of war that was developing. The Heinkel He-111, the Dornier Do-17, even the later Junkers Ju-88 were all excellent aircraft in their own right. But they had been designed for a different kind of war, one of rapid advance and tactical support. The B-17 was designed for strategic bombing, for missions deep into enemy territory without fighter escort, for absorbing punishment and pressing on. The Luftwaffe tried to apply the lessons learned from studying the B-17 to their own designs. Armor was increased, defensive armament was enhanced, structural strength was improved. But these modifications came too late and were never as comprehensive as the Americans' integrated approach. The B-17 had been designed from the ground up around these principles. German bombers were being retrofitted, and it showed. But the Germans didn't just study the B-17 to improve their own aircraft. They also wanted to find its weaknesses, to develop tactics that could bring these bombers down more effectively. The test pilots at Rechlin flew mock combat missions, trying different approach angles, different attack patterns. They found that frontal attacks, coming straight at the bomber before the American gunners could train their weapons effectively, were the most successful. This led to the development of new tactics and heavier forward-firing armament on German fighters. The Germans also discovered that the B-17, for all its strengths, had some vulnerable points. The engines, while tough, could still be disabled with concentrated fire. The oxygen system, critical for operations at high altitude, could be damaged, forcing the bomber down to lower altitudes where it became more vulnerable. And while the bomber could survive tremendous damage, there were limits. Enough hits in the right places would still bring it down. The most intriguing use of captured B-17s came from a secretive Luftwaffe unit known as Kampfgeschwader 200, or KG-200. This unit specialized in covert operations using captured Allied aircraft. They flew several B-17s that had been repaired and restored to flying condition. These aircraft, wearing German markings, were used for a variety of missions. Some were used to infiltrate American formations, gathering intelligence on tactics and procedures. Others were used for signals intelligence, monitoring Allied radio communications. There were even missions where these German-flown B-17s were used to drop agents behind Allied lines, the familiar silhouette of the flying fortress, ensuring they weren't fired upon until it was too late. The German pilots who flew these captured B-17s for KG-200 had a unique perspective. They experienced firsthand what American crews dealt with on every mission, the physical demands of flying such a large, heavy aircraft. The noise, the cold, the constant vigilance required to watch for fighters, and they gained a grudging respect for the men who flew these missions day after day. One German pilot who flew captured B-17s later wrote about the experience. He described the aircraft as honest and forgiving. It didn't have the crisp, responsive handling of a fighter or even of German bombers, but it was predictable. It told you when it was reaching its limits, and most importantly, it would bring you home even when you thought all was lost. He admitted that if he had to go to war in a bomber, he would choose the B-17. The engineers at Rayclin eventually produced a comprehensive technical report on the B-17. This document, hundreds of pages long, detailed every aspect of the aircraft's design and performance. But buried in the technical specifications and performance charts was a conclusion that must have been difficult for German engineers to write. The B-17 Flying Fortress represented a triumph of integrated engineering design. It was, in their assessment, the toughest combat aircraft they had ever evaluated. This admission didn't come easily. German engineering pride was legendary. Their tanks, their submarines, their jet aircraft all represented cutting-edge technology. But the Americans, whom many Germans had dismissed as mechanically minded but lacking in engineering sophistication, had created something that simply worked better in the brutal crucible of aerial combat. The impact of the B-17 on the air war over Europe cannot be overstated. Between 1942 and 1945, B-17s flew over 290,000 sorties, dropping more than 500,000 tons of bombs on enemy targets. The 8th Air Force alone lost over 4,700 B-17s in combat, and thousands more were damaged. But the missions continued, the formations kept flying, and the strategic bombing campaign ground on. The Germans threw everything they had at these bombers. They developed specialized anti-bomber fighters armed with heavy cannons and rockets. They created new tactics, new weapons, new strategies. The Luftwaffe's fighter pilots became experts at attacking B-17 formations, knowing exactly where to aim, how to approach, when to break off. And still, the fortresses kept coming. The psychological impact was significant. Luftwaffe pilots knew that even when they scored hits, even when they saw pieces flying off a B-17, it might still make it home. This affected their morale, their confidence in their weapons. The Americans had created a machine that was more than an aircraft. It was a symbol of industrial might and engineering capability. German engineers continued to study captured B-17s throughout the war, always looking for new insights. Later models, particularly the B-17G, with its chin turret to counter frontal attacks, were examined with the same thoroughness as earlier variants. Each improvement the Americans made was documented, analyzed, and, where possible, countered. But the fundamental lesson remained unchanged. The Americans had approached bomber design from a different angle than the Germans, and for the mission they needed to accomplish, their approach was superior. This wasn't about one nation's engineers being smarter than another's. It was about matching design philosophy to mission requirements. The Germans needed bombers that could support rapidly advancing ground forces, that could operate from rough fields close to the front lines, that could be produced quickly and maintained easily. Their designs reflected these needs. The Americans needed bombers that could fly hundreds of miles into hostile territory, fight their way to the target, and return to bases in England. The B-17 reflected that need. The The story of the captured B-17s and what the Germans learned from them is really a story about how engineering serves strategy. The Americans had decided that strategic bombing would be a key part of their war effort. They had committed to daylight precision bombing, a strategy that demanded a specific kind of aircraft. And Boeing had delivered exactly what was needed. The durability of the B-17 became legendary. There are countless stories from the War of Fortresses returning from missions with damage that defied belief. There's the famous case of a B-17 that collided with a German fighter, cutting the fighter in half but losing 10 feet of its own wing in the process. That bomber made it back to England and landed safely. The pilot said the aircraft vibrated so badly he thought the wings would tear off, but the old bird held together. Another B-17 took a direct hit from anti-aircraft fire that blew a massive hole in the fuselage. The hole was large enough that crew members could see completely through the aircraft from one side to the other. Aerodynamically, the bomber should have been unflyable, but the structure held. The pilots fought with the controls, and they brought it home. The ground crew who saw it land couldn't believe it had stayed in the air. There was a bomber that lost its entire nose section, including the bombardier's position, in a mid-air collision. The pilot couldn't see forward. The aircraft was massively out of balance. But the strength of the B-17 structure meant that the rest of the aircraft remained controllable. They navigated by looking out the side windows and landed back at base, to the astonishment of everyone who saw them approach. These weren't isolated incidents. They happened over and over again throughout the war. B-17s absorbed punishment that would have destroyed other aircraft and kept flying. The German engineers who studied these bombers understood the technical reasons why this was possible. But even understanding the engineering didn't fully explain it. There was something almost mystical about the Fortress's ability to survive. The crews who flew them certainly believed in the aircraft. They gave their B-17s names, painted nose art on them, treated them as more than machines. There was Mary Ruth, Memphis Belle, Yankee Doodle, and hundreds of others. Each bomber had a personality, at least in the minds of the men who flew them. And that faith in the aircraft, that trust that the old girl would bring them home, was itself a kind of weapon. The German analysis of the B-17 eventually concluded that the aircraft represented a perfect example of design optimization for a specific mission. Every ton of weight, every structural member, every system served the purpose of getting 10 men and several tons of bombs to a target and back. There was no wasted elegance, no unnecessary features. It was functional engineering at its finest. One German engineer in a post-war interview was asked about the B-17. He smiled sadly and said that it was the aircraft that taught them humility. They had thought their engineering was the best in the world. They had thought their designs were superior. And then they studied the Flying Fortress and realized that the Americans had simply asked different questions and had come up with different, equally valid answers. Sometimes, he admitted, those answers were better than their own. The legacy of the B-17 extends far beyond the Second World War. The design philosophies embedded in its structure, the emphasis on survivability and crew protection, influenced post-war bomber design around the world. The Soviets studied captured B-17s and incorporated lessons into their own designs. The British, who had worked alongside the Fortresses, applied similar principles to their post-war aircraft. The Americans, of course, continued the philosophy with the B-29 Superfortress and later bombers. But perhaps the greatest legacy is the respect the B-17 earned from its enemies. The German engineers and pilots who encountered it, who studied it, who fought against it, came to admire it. Not because it was invincible, it wasn't. Nearly 5,000 B-17s were shot down during the war. But because it represented excellence in engineering, it did exactly what it was designed to do, and it did it better than anyone had thought possible. The toughness of the B-17 has become part of aviation legend. Stories are still told about individual aircraft and their crews. Historians continue to study the technical details, the combat records, the personal accounts. Museums around the world display preserved B-17s, and vintage aircraft organizations maintain flying examples, keeping the legacy alive. For the German engineers who captured and studied these aircraft during the war, their work produced insights that would have been impossible to gain any other way. They learned about American industrial methods, about different approaches to design challenges, about the importance of integrated systems thinking. They learned to respect an enemy's engineering capability, even as they fought against it. The B-17 Flying Fortress was not perfect. It had limitations. Its range was shorter than some later bombers. Its bomb load was smaller than the British Lancaster. It was expensive to build and maintain, but for the mission it was designed to fly. For the strategy it was meant to enable, it was very nearly ideal. And that's what great engineering is. Not creating the best of everything, but creating the right tool for the job. The American bombing campaign over Europe was controversial then and remains debated now. The strategic value, the moral implications, the cost in lives on both sides, all of these are legitimate subjects for historical discussion. But separate from those debates is the technical achievement represented by the B-17. It was a machine designed to do an incredibly difficult job under the worst possible conditions, and it succeeded. The German engineers who examined captured B-17s were doing their duty, trying to find ways to defeat an enemy weapon. But they were also engineers, professionals who could appreciate excellence when they saw it. Their reports, their analyses, their grudging admissions of the fortress's capabilities all testify to the quality of what Boeing and the American aviation industry had created. In the end, the B-17's toughness came down to thousands of engineering decisions, each one small, each one adding a bit more strength, a bit more redundancy, a bit more survivability. There was no single secret, no one clever trick. It was comprehensive, integrated design thinking, focused ruthlessly on a single goal: bring the crew home. The German engineers admitted they had never seen anything so tough. That admission, from men who worked with some of the most advanced technology of their time, from a nation proud of its engineering prowess, is perhaps the highest compliment the B-17 Flying Fortress could receive. It was tough enough to earn the respect of those who fought against it. It was tough enough to become a legend, and it was tough enough to help win a war. The Boeing B-17 Flying Fortress flew its last combat mission in May 1945, but its legacy continues. When engineers design aircraft today, when they think about survivability and crew protection, when they consider how to build something that will function even when damaged, they're following principles that the B-17 exemplified. The Fortress set a standard for what a combat aircraft should be, and that standard endures. For the men who flew them, the B-17 was more than metal and engines. It was their home above the clouds, their protection against the enemy, their ticket back to base after missions that tested the limits of human endurance. They trusted it with their lives, and more often than not, the trust was rewarded. That's what the German engineers couldn't fully capture in their reports. They could measure the strength of the structure and analyze the efficiency of the systems, but they couldn't quantify the bond between crew and machine. The story of German engineers capturing a B-17 and admitting they'd never seen anything so tough is really a story about engineering meeting reality. In the clean rooms and drawing offices where aircraft are designed, it's easy to optimize for performance, to chase the highest speeds or the longest ranges. But in combat, what matters is whether the aircraft brings its crew home. The B-17 did that better than any other bomber of its time, and the Germans learned that lesson the hard way, one captured aircraft at a time.